So this was a pop quiz, the one which was related to MCQs from different topics. Now weekly you will solve a pop quiz which is having MCQs only, and the second pop quiz of the week will have structure questions. In the first question, which equation represent a chemical change? When we say a chemical change means a new substance should form. When we say dissolving, like dissolving of a salt, it's not a chemical change. Dissolving of a salt is a physical change. So if you check the option A, we have barium chloride, which is solid and it turned into a liquid. So when a solid turned into a liquid, that is called a melting. So this is not a this is not a chemical change. This one is a physical change. Calcium ion reacted with sulfate ion to form a solid calcium sulfide. So like calcium ion from a solution and sulfate ion from the solution, and they're separate, but they combine and they form a calcium sulfate. So a new substance is formed. Like ions are forming a new calcium ion was separate, sulfate ion was separate, turned into calcium sulfate, a solid. When you check option C, so B is the right answer. When you check option C, potassium chloride is there, which is solid. When we add this to water, it turned into potassium ion and chloride ion. So what actually happened? It's a dissolving. Dissolving is not a chemical change. Dissolving is a physical change. Like you have ionic compound is there which contain potassium ion and chloride ion. When you add, potassium ions are separate and the chloride ions are separate. There's no new substance from here. It is just. But what about this one? In this one, like maybe it was calcium nitrate and maybe it was sodium sulfate. When they mixed with each other, it formed calcium sulfate. This ionic equation is written. That's why B is right. What about option D? Sodium ion, nitrate ion become aqueous sodium nitrate. So they're already aqueous. Like it also means the same thing. It means the sodium ions are also in the solution and nitrate ions are also in the solution. No change happened. Only thing what happened is like the way we are writing like sodium ion, positive sodium ion is there and nitrate ion is negative, which is aqueous, means dissolve. And then it form sodium nitrate, NaNO3, that is also aqueous. So when we say something is aqueous, it means it will exist as an ion, the ionic compound. So this is same as the first one. So there is no change happening. That's why option B is the right answer for this. Which sample contain the largest number of molecules? To work out the number of the molecules, you simply find the moles. The one which is having the greater number or the highest number of the moles, that will have the greater number of the molecules, because 1 mole of a substance have 6 exponent 23 particles, atoms, molecules, ions. So simply we have to find the moles of each. The one which give a higher number, that will be the answer. So how to work out the moles of methane? Because the mass is given, so how to work out the moles? Moles equal mass in gram divided by molar mass. What is the molar mass of a methane? Carbon is 12 plus hydrogen is 1 into 4. So that will make 16. So 16 divided by 16, what we'll get? We'll get 1 more. What about oxygen? How to work out the moles of oxygen? We have the mass, which is 16. What about the molar mass of oxygen? It's O2, so it will be 16 multiplied by 2, which is 32. So 16 divided by 32, that will be equal to 0.5 moles. What about phosphorus? 16 gram of phosphorus solid. So mass in gram is 16. And what is the mass of phosphorus? 31. And how many phosphorus are there in this? That is 4. So it will be 16, 31 multiplied by 4. So it will be 124. So this will be 0.13. When we check, we have the volume of a gas is given. So when volume of a gas is given, we don't need the mass. To work out the moles, moles is volume of a gas in dm cube divided by molar volume, which is 24. So 16 divided by 24, that's equal to 0.66. So the one which is having the highest number,
बंद कर दो चिप
so we have 16 gram of a methane is there. So 16 divided by 16, that will give us 1. We have 16 gram of oxygen, so 16 divided by 32, which is 0.5. We have 16 gram of a phosphorus, so it will be 16 divided by, so that will be 0.13. And for a methane, it will be 16 divided by 24, so 0.66. So which one we are having the highest number? So if we are having for A the highest, then A should be the right answer. Clear? Is it clear this one? So if the mass is given, we will use the moles equal mass in gram over molar mass. If the volume is given, that will use the moles equal volume of a gas divided by 24. The next one, the concentration of a sample of a dilute aqueous sodium hydroxide is found by titration. The apparatus is shown. Which information is needed to calculate the concentration of aqueous sodium hydroxide in DMQ? So first what we do, how it is done, these type of experiments, the titration. So this solution should have a known concentration. We know the concentration of this solution. And how much volume we remove using a burette, we'll know how much volume is removed. So moles equal concentration into volume. So concentration multiplied by volume will get the moles. And after getting the moles of this, we'll use the mole ratio, we'll get the moles of sodium hydroxide. And because in the question, we need to calculate the concentration. So to get the concentration, what we need moles and we need volume. And we have to know the volume of sodium hydroxide. So we have to take which information we need. Do we need the concentration of hydrochloric acid? Yes, we need the concentration of hydrochloric acid. Do we need the volume of hydrochloric acid? Yes, we should know the volume of hydrochloric acid. Do we need the molar mass of hydrochloric acid? We don't need the molar mass because what we'll do, concentration into volume will give us the moles of HCl. And from moles of HCl, we'll use a ratio and find the moles of sodium hydroxide. So we need the volume of sodium hydroxide. And from volume of sodium hydroxide, do we need the molar mass? We don't need a molar mass. Why we don't need a molar mass? Because we don't have the mass of this. So the idea is that like we'll have the concentration of hydrochloric acid. We multiply it by the volume, we'll get the moles of HCl. After getting a moles of HCl, we'll use the mole ratio and we work out the moles of sodium hydroxide. And moles of sodium hydroxide divided by volume of sodium hydroxide will get the concentration. So the correct answer for this one is B. Is it clear? In question 4, in an experiment, aqueous copper 2 sulfate is electrolyzed using the copper electrodes, graphite electrodes, and using the copper electrodes. Look, when we do electrolysis, the results will be different depending on the electrodes which we are using. If we are using a graphite electrode, like example, these are representing the graphite electrode, and the same experiment is done by using the copper electrodes. It's an aqueous copper 2 sulfate solution. So the ions which are present here, it contain copper ion. it contains sulfate ion, it contains hydrogen ion and hydroxide ion. Same thing, this contains copper ion, sulfate ion, hydrogen ion and hydroxide ion. This one is a positive electrode in anode and cathode, and this one is positive anode and cathode. The electrode is made up of copper, both cases in here. The other one is graphite. Graphite is unreactive or inert electrode, it does not react. But when we use a copper and the copper solution, then it will be an active electrode, like it will change during electrolysis. So for positive ion, what will happen? We check the reactivity, which is less reactive positive ion here, copper or hydrogen. So copper is less reactive positive ion. So what is the equation at cathode? The copper ions are there, they will gain electron and it turn into copper atom. When it turn into a copper atom, the copper will stick to the cathode and the cathode size will increase. Same thing happen here. When we check this, if you are using a copper electrodes, the first reactivity, copper is less reactive, so it will move towards the cathode. And the same thing will happen. Copper ions gain electron, turn into copper atom. As a result, this copper will stick to the cathode and the cathode size will increase. For negative ion, what will happen? We check the amount, like which is more, but sulfate, nitrates, and carbonates never move. So because there's a sulfate ion, so this sulfate ion will never move, so hydroxide will move. Whenever hydroxide ion will move there, so when 4 hydroxide ions are moving there, it will give oxygen plus 2 water molecules plus 4 electrons. So the observation, because oxygen is a gas, so we'll observe bubbles. But opposite will happen here, because as the amount of the copper ion in the solution is decreasing, to balance that, the copper atom will go inside the solution as a copper ion. And what will the equation for anode in this case? So copper atoms turn into copper ions by loss of 2 electron. And what happened to the size of this anode? The size of anode start to decrease because the copper atoms are turning into copper ion. So we have to check the statements, which statements are, this is what happened in electrolysis. The question is, which statement identifies the half equation that at one of the electrodes? In experiment 1, like this is experiment 1, the half equation for anode, 4 hydroxide ions are there. They will give water plus O2 plus 4E. So is it correct? The experiment 1, yes, it is correct. So in experiment 1, the half equation for cathode, hydrogen does not move there, so it should be copper. In experiment 2, half equation for anode is, it's not copper ion turn into copper atom, it should be opposite, it should be copper atom turn into copper ion. And in experiment 2, half equation, hydroxide does not move there. That's why option A is the right answer for this. So this is very important. You have to learn the product for the electrolysis of aqueous copper to sulfate solutions using the graphite electrode and using the copper electrodes. And the observation as well. So one is bubbles and the solid cathode size increase. Another one, cathode size increase, anode size will decrease. And the solution, there will be no color change. But here in this case, when we use a carbon or a graphite electrode, the solution will turn lighter or paler because the amount of copper ions in the solution will decrease. Is it clear? Question 4. In question 5, which substance is not produced during electrolysis of concentrated aqueous sodium chloride? So if you're, and if they did not mention about the electrodes, then you will consider that these electrodes are made up of graphite. So we have anode is there and we have cathode, and the solution or the electrolyte, we have aqueous concentrated, so sodium chloride. So sodium ion is there, the chloride ion is there, the hydrogen ion will be there, and hydroxide. So for positive ions, we always check the less reactive. So which is a less reactive positive ion? So hydrogen is a less reactive positive ion and it will move towards cathode. So what will the equation for cathode? When two hydrogen ions are there, they will gain two electron and it will form a hydrogen gas. So as a result, because there's a hydrogen gas, so we'll observe bubbles. For negative ions, we check the amount, the sulfate, nitrate, and carbonate never move. But in this case, we have one is chloride, another one is hydroxide. So the chloride ions, because it's a concentrated, so solution contain more chloride ion, less hydroxide ion. So the chloride ions will move there. When two chloride ions will move there, they will, you can write electrons on both the other side, like they will lose two electron and it will form a chlorine gas. So chlorine gas is there, light yellowish green gas will be given off or a bubbles will be there. So, and what happened to the solution? Because the chloride ion and hydroxide ions move there. So what we are left with? We are left with sodium hydroxide. From where we get hydroxide? Because they mention here aqueous. Aqueous means water. And what is the ionic composition of a water? It contain H ion and it contain OH ion. If you say it's a concentrated, it means it contains less water, less H and OH ion. If you say it's a dilute, it means it contains more H and OH ions. So is the chlorine formed? Yes. Is the hydrogen formed? Yes. Is sodium hydroxide formed? Yes. But which is not formed is sodium. Is it clear? Any doubt on this? Question 5. Next is methane burns in excess of oxygen. The equation is shown. The bond energies are shown. What is the energy change for this reaction? We don't have to calculate the final answer. We just have to show the method. Like whenever a equation is given, what you will do first, you will draw the molecule to identify how many bonds are there. Oxygen is double bond and there are two molecules. CO2, carbon, oxygen, there's a double bond. And H2O is HONH and HONH. So reacting side is a bond breaking side. The product side is a bond forming side. To get the energy change, it is a bond breaking minus bond forming. So there are four CH bonds. So each CH bond, how much is the bond energy? 410. So 4 multiplied by 410. Plus oxygen double bond with oxygen is 296. And how many of them? So there are two of them. So it will be 2 multiplied by 496. So if you see that which one, like if you see even the option A, like 4 multiplied by 410 and 2 multiplied by 496, so none of them have this value. So even when I start to write, this is the bond breaking side minus the bond forming side. OC bonds are there. What is a CO or OC bond? 805. So this will be 2 multiplied by 805 plus then OH bonds are there or HO bonds are there, which is 460. So it will be 4 multiplied by 460. So it matches with option A. So bond breaking minus bond forming will give us the energy change of this reaction. Which change increases the rate of a reaction by decreasing the activation energy? Activation energy can only be changed by using a catalyst. So for a chemical reaction, if we use a catalyst, we can only change the activation. Rest all of them can, like we can change the energy of particle, but not the activation energy, the minimum possible energy to start up the reaction. So adding a catalyst, addition of a catalyst will lower the activation energy. Decrease in size of the particle of solid reactant, that will increase the rate, but it will not change the activation energy. Increasing a concentration, it will increase the rate, number of the, this will, what it will do, it will also increase the rate, but how it increases the rate? By lowering the activation energy. Like if you have energy profile diagram, for example, an endothermic reaction. So this is, if this reaction was without catalyst, so if you use a catalyst, the same reaction can happen at lower activation energy. Increasing a temperature also increases the rate or increases the proportion of the particles or number of the particles which have energy more than activation, but it does not alter the activation energy. So remember, activation energy can only be changed by addition of the catalyst. In the contact process, sulfur dioxide is reacted with oxygen to form sulfur trioxide. Which conditions are used? There are certain chemical reactions, especially reversible reactions, you have to learn these conditions. So one is the manufacture of sulfuric acid or a sulfur trioxide by a contact process. Another one is manufacture of ammonia by a Haber's process. First thing, the catalyst which is used for sulfur trioxide, that is vanadium pentoxide V2O5. So vanadium pentoxide, so either, because the catalyst is vanadium pentoxide, so either B can be an answer or C can be an answer. Then at what temperature it is done? It is done at 450 degrees centigrade. This is a fixed reaction condition. And what about the pressure? The pressure is about 200,000 Pascal or 200,000 Pascal, or you can say 2 atm or 200 kilopascal, or also known as 2 atm. So these are the reaction conditions for a contact process. You have to learn. We will discuss this like about the chemistry of environment. In chemistry of environment, you will learn these conditions as well. So this is related to memorizing the condition. Which reaction is reversible? So which is a reversible reaction? An iron nail rusting when iron left in the moist air. So rusting of iron, what will happen? It will form a hydrated iron oxide, like when iron is there and oxygen and water molecule. So it will form a hydrated iron 3 oxide. But we cannot reverse rust back to the iron and oxygen and water, so it is irreversible. Limestone reacting with acid to form, so limestone, calcium carbonate is there, reacted with any acid like hydrochloric acid. It will give calcium chloride plus carbon dioxide plus water, H2O. We cannot reverse this reaction. Magnesium burning in air. So when magnesium burn in air, magnesium plus oxygen, it will give magnesium oxide. So this is, again, it's irreversible. Like once magnesium oxide is formed, you cannot reverse. Anhydrous, remember one thing, when anhydrous salt convert into hydrated or hydrated salt convert into anhydrous, these changes are reversible. What is the meaning of anhydrous copper sulfate? Anhydrous, because what these ionic compounds, how these ionic compounds exist, they exist as a lattice. So we have a lattice or a crystal of copper sulfate. This is CuSO4. What is the meaning of hydrated copper sulfate? Because the state will not change, like it will remain in a solid state, but within the structure, it will trap the water molecules. So the water molecules are trapped within the structure. Usually trap 5 water molecules. So when both of them are solid, and this is CuSO4.5H2O. So both of them are solid, but what is the difference here? One is anhydrous. Anhydrous means like the crystals does not have any trace of water molecules. Another one is a hydrated. Hydrated means the crystals trap some of the water molecule. So these changes are reversible. How these changes are reversible? Like if I add a small quantity or a small amount of water, it will turn into this. If I supply heat energy, it will turn back into copper sulfate. So this change can be reversed. So hydrated to anhydrous salts, it's always a reversible change. That's why D is the right answer for this. In question 10, this equation for a reaction of sulfur dioxide with acidified potassium dichromate 6 as shown. What is oxidized and what is oxidizing agent? The substance which is oxidized is a reducing agent, and the substance which is reduced is an oxidizing agent. How to identify this? So first what you have to do, you have to write the oxidation number for whenever there's a compound or a molecular ion, you write the oxidation number for each element. Like when we talk, you don't bother about what coefficient is written, you just take the compound. So when we take compound, using the elements which are on the right hand side, we use their group number. So element group 1 will have oxidation number +1, +2, +3, -4, -3, -2, -1, and 0. So in sulfur dioxide, how many oxygen? Oxygen first, because we start with the right hand side. First, we start with the right hand side, right according to the group number, and the left hand side, if it's a neutral molecule, then it should have the same. Total should be 0. So oxygen belongs to group 6. So as oxygen belongs to group 6, it should be -2. How many oxygen are there? 2. So the total number, I'm not saying individual is -2, each is -2, but the total will be -4. So if total is -4 and it's a neutral molecule, like sulfur dioxide does not have a charge. So what should be the oxidation number for sulfur? It will be +4. Because when molecule is neutral, the sum of oxidation number should be 0. When the molecule is like it's a molecular ion is there or a charge is there, then the sum of oxidation number should be equals to the net charge. So in a sulfur dioxide, sulfur is +4. Now move on to the next one. The dichromate ion. Even it's given, if even it is written here, it is +6. As you can see, the chromium is +6, but I will explain how it is +6. One oxygen is -2. What is it for 7 oxygen? What should be the total? 1 is -2. So 7 will be -14 because -2 multiplied by 7, -14. The total charge should be -2, means the result should be -2. So what should be the chromium oxidation number? The total. I want the result final to be -2. What should be the chromium? So it means it should be +12 because +12 -14 will give us -2. So what is the oxidation number for each chromium? Because 2 chromium have +12. So each chromium will be +6. Here hydrogen, when ion is there, the oxidation number of hydrogen is +1. Because when directly ion is written, it means the charge on the ion is always the oxidation number. Move on to sulfate ion. For sulfate ion, each oxygen is -2, so there are 4 oxygen. So what should be the total number? The total number will be -8. So what should be the oxidation number of this sulfur? We want the result to be -2. So what should be the number here? So the number should be +6 because +6 -8 will give 2 minus or -2. Chromium, as I mentioned, the charge what is written, so +3 is there. In case of a water molecule, each oxygen is -2, so the hydrogen should be +2. But when we check the oxidation, like when we check whether it's oxidation or reduction, we check for individual elements. So 2 hydrogen are +2, so 1 hydrogen will be +1. This equation, I have written all the oxidation number for this equation. Now we check if there's an increase in oxidation number. What we call this change? We call this change as oxidation. If there's a decrease in oxidation number, what we call this change? We call this change as reduction. And for a substance which reduction happen is an oxidizing agent, and a substance which oxidation happen is a reducing agent. So sulfur is +4, and then sulfur is +6. So +4 changes to +6. What is this change? So what we say, increase in oxidation number, what we say? Is this oxidation or reduction? +4 become +6. Oxidation. So this change is oxidation. Or we can say the sulfur dioxide is oxidized. When you check for chromium, because we check for individual, so total is +12, but each chromium is +6, and here each chromium is +3. So +6 become +3. What happened in terms of oxidation number? It has decreased, so this changes reduction. And for substance which reduction happen is an oxidizing agent. So which is an oxidizing agent? So Cr2O7 with a charge -2 is an oxidizing agent. So sulfur dioxide is oxidized and Cr2O7 is an oxidizing agent. And for substance which oxidation happens, so opposite will be the reduction. So A will be the right answer. This is one way of getting in terms of oxidation number. There is also another way. What is the second way? It is in terms of oxygen. When increase in oxygen, what we call this change? Oxidation. So sulfur dioxide is SO2, like 2 oxygen, and sulfate ion is 4 oxygen. So what happened in terms of oxygen? Increase. So if oxygen increase, what we call this change? We call that as oxidation. Cr2O7 becomes Cr. So what happened in terms of oxygen? Reduction. Like oxygen is decreased, so this will be a reduction, or it will be an oxidizing agent. So again, with reference to that, you will also get A. And what happened to the hydrogen ion? If you see in this part, it become, so increase in oxidation number is not an oxidizing agent here, because oxidizing agent, it must be a reduction, not oxidation. Yes, you can do this question by increase in oxygen, or you can also do in terms of oxidation numbers. But electrons, the example of electrons cannot be used here as there are no electrons in this example. Is it clear, this one? Anyone having a doubt or a question? This was the pop quiz, which was related to all MCQs were there in this one.